All right, so once you get the two equations written down, I want you to take a look at them, and I want you to use the word eliminate in your thought process. Are there any two letters or terms that you could look at and say, hey, those can easily be eliminated? Like, which ones you thinking about? X's or Y's or constants? Xavier?
Negative 3x.
Yeah, look at the X column. I got a negative 3x and a positive 3x. And the neat thing is, when I add those two together, they kind of cancel out. They eliminate each other. So I'm going to put like a fraction bar here, kind of like a sum bar, 2 plus 3 equals 5. I'm going to cross them out. When you add those two together, they disappear, hence the phrase eliminate. And now add the negative 6y and the positive 5y, you get negative 1y underneath it. I keep y's under y's and x's under x's. And then take the 12 and the negative 7, add those together, you get positive 5. Now you're not done yet, because now you have to divide by negative 1s, and y equals negative 5. That's a lot easier to get than it was using substitution method. I think fewer steps, per se. All right, so now I know that negative 5 is the y coordinate. All right, now here's the downfall. Y was really easy to get. X will not be as easy to get. You can pick either equation that I first began with. Either put negative 5 in place of the y in the first equation, or the second equation and solve for x. And this is the long part. There's a trade-off. Maybe I'll pick the first equation. And so negative 3x minus 6 times negative 5 equals 12, which is negative 3x plus 30 equals 12. Now you do your mother-in-law, subtract 30 on both sides.
Negative 30?
No, because the negative 6 and negative 5. Let's see, negative 3x equals negative 18. And now divide everything by negative 3's. Who's got negative 18 divided by negative 3? Eddie? Positive 6. So this is what's called the elimination method, because you eliminate one of the variables and solve for the other. I don't know if it's a time saver or not. I just like this method better than I do substitution method, but that's up to you. So there's our first example. Eliminate, solve for a variable, use that variable in the next equation, like I did over here. Solve for x, and you're all done. There's your ordered pair, 6, negative 5. Now let's try a second equation. Same type. Now let's do negative x minus y equals negative 2. And underneath it, this is where you have to stack them. I didn't do that last time in substitution, but you have to this time. Equals positive 2. All right. Well, very easy to see who will be eliminated, like Arnold Schwarzenegger. Be eliminated. Hear me now, believe me later. Brandon? Say it again. You can't pick both. I want a letter to eliminate. So, Brandon? Yeah, the x's. All right, so when you add the columns together, negative x and positive x, gone, eliminated. Hear me now, believe me later. Like the Terminator. And then you got the y family. Well, negative y plus 5y is positive 4y. So now you're going to add your y's together, and then add your negative 2 and positive 2. That does become 0. Now divide by 4, and y equals 0. That was easy. Okay, I got my y number. It is 0. Now comes the, I'm not going to say hard part, the long part. Is now finding out what x is. So either use equation number 1 or equation number 2, and put 0 in place of the y. And now you're in charge of solving for x. This one's pretty simple. Your negative x equals negative 2. When you divide by negative 1s everywhere, you have x equals positive 2. That one's a little bit shorter than number 1. The same procedure. Eliminate either x or y, and solve for the other one. And then do substitution property. And bada bing, bada boom. There you go, 2, 0. So the example number 2 of elimination method. Right now, this is like called phase 1. Right, how about one more here? I have time. Yeah, time for another one. All right, example number 3. And this is called like the first phase. There's like 3 different phases of this. All right, I got negative 5x plus y equals 15. And then 4x minus y equals negative 12. Guess what letter you eliminate first? Cece? The y's, yep. When you add them together, they disappear. They're canceled out. Now the x's. Negative 5x and a positive 4x is negative 1x. And the equal sign. And 15 and negative 12 make positive 3. Now divide by negative 1's. And x equals negative 3. So there is the first coordinate of the intersecting point, negative 3. Now comes the part where it's a little bit longer, not harder, but longer. Now pick either equation 1 or equation 2 and solve for y. I'll just pick the first equation, just a creature of habit. So negative 5 times a negative 3 plus y equals 15. See, negative 3 times a negative 5 is positive 15 plus y equals 15. Subtract 15 from both sides. Oh, how easy is this? Nice. Got a 0. It's done. Negative 3 is 0. Yeah, so I did 3 out loud with you. Let me give you one. We got like 5 minutes left of class. I'll give you the last one here. Then we'll call it a day. Try it out, and then I'll do it out, and then we'll be on our way to your specials. And so here's my last one. All right. 4x minus 2y equals 6. Negative 4x plus 6y equals negative 10. All right, give it a shot. All right, so the x's are the ones that are eliminated. I kind of cross them out. If I put the y's together, negative 2y and positive 6y is positive 4y. And then put 6 and negative 10 together, you get negative 4, excuse me. Now divide everything by 4. I got y equal negative 1. So there's half of my answer key. Y is negative 1. All right, I have my choice. I get the first or second equation. I'm just going to do the first equation, guys. All right, 4x minus 2 times negative 1 equals 6. Now, be careful. The minus 2 times negative 1 ends up being 4x plus 2 equals 6. Then subtract 2 from both sides. 4x equals 4. And divide by 4's. I'm getting positive 1, negative 1. Remember, if you're in doubt, take x and y, put them back in place of their letters, and then see if you get 6 for the first equation and negative 10 for your second equation, and that's how you know it's done correctly. And that right there is just the intro to elimination method.